U.S. intelligence pointed to Osama bin Laden hiding in the mountains of Afghanistan within the cave complexes several hundred feet below the ground. Then, in March of 2002, the Department of Defense and the United States Air Force unleashed their newest weapon on top of the al-Qaeda and Taliban forces. Developed under unprecedented circumstances, with scientist Nguyet Anh Duong at the helm, the BLU-118 B thermobaric bomb was built in a rush, ignoring most safety procedures and previous testing due to the urgency. Once it was finally ready, it proved so lethal that many experts believe it should never have been created at all. But as tensions rose in the Middle East, the U.S. forces nervously hoped that the thermobaric weapon would penetrate deep into the ground and destroy the cave complex once and for all. March 2002. Developed in the 1980s, the McDonnell Douglas F-15E Strike Eagle was designed to meet the United States Air Force requirements for an all-weather multi-role strike fighter capable of air-to-ground missions that could carry up to 23,000 pounds of air-to-ground and air-to-air weapons. Going back to its introduction in 1988, the multi-role strike fighter has been at the center of every major conflict the U.S. has been involved with, from Desert Shield to Operation Inherent Resolve and many others. Then, on March 2, 2002, in an undisclosed location near or around Afghanistan, a single F-15E Strike Eagle belonging to the 335th Fighter Squadron Chiefs from the 4th Fighter Wings took off from the Anaconda Mountains near the country's eastern border. Hanging from its racks, the Strike Eagle carried the first operational BLU-118 B thermobaric bomb, the United States' newest anti-terrorist weapon. The aircraft was taking part in Operation Anaconda, a joint military operation between the CIA paramilitary officers and several allies attempting to destroy al-Qaeda and Taliban forces. Mission soldiers had found a tactically significant cave complex that, according to then Chairman of the Joint Chiefs of Staff, General Richard Myers, was crowded with essential enemy personnel. Tagged with a targeting laser, the F-15's computer carefully calculated the height, speed, and range, and released the weapon directly towards the tunnel complex's entrance, set near a house-like structure. As the bomb's fins and airfoils twisted and tweaked, the free-falling weapon set course to the ground, right to the end of the aircraft's laser beam. However, the bomb missed the target, and even though the details are classified, the Pentagon did announce that the bomb missed the cave because it detonated early, wasting all of its earth-shuddering energy above ground. Still, to the bomb's maker, the actual explosion was all that mattered. Thermobaric weapon. In July of 2001, Lieutenant Colonel Tom Ward arrived at the Department of Defense's offices, ready to comply with their request to develop a tunnel defeat weapon to potentially be used in North Korean subterranean nuclear stockpiles. The weapon needed to be capable of punching inside caves and flushing them out. Although Ward had never built a bomb, as a veteran project manager, he met with scientists and contractors, ran the numbers, and prepared a proposal to make 20 warheads that would test a thermobaric explosive. According to the mapped-out schedule, the project would cost around $67 million and take about 3 years. Less than 2 months later, everything changed with the 9/11 terrorist attack, including the objectives of the Defense Threat Reduction Agency, as it was now thrust into a leading role in the new and uncertain war on terrorism. Ward's thermobaric weapon was urgently needed, and he looked for available parts to create the new bomb, choosing the BLU-109 casing penetrator. Developed by Lockheed Martin, this inch-thick casing could demolish through 6 feet of concrete before detonation, which was perfect for targeting a cave complex. On October 11th, only 4 days after the official declaration of war in Afghanistan, Ward promised the Pentagon a bomb in 60 days. But although he had a plan to assemble the steel and the electronics, he still needed a lethal payload. At the time, there was no explosive in the world capable of doing what the new bomb was intended for, and Ward had no time to experiment with different chemical compounds as he wanted. What he needed was help from the best explosive scientist in America. Nguyet Anh Duong. When Nguyet Anh Duong arrived in Maryland in 1975 as a refugee from the Vietnam War, she promised that she would repay the United States for welcoming her and her family with open arms. As such, Duong decided that working with the Defense Department was the perfect way to fight for freedom and help preserve the country's integrity. When the war in Afghanistan started, Duong was the program manager for explosives at the Naval Surface Warfare Center Indian Head Division. An internationally recognized scientist, the 42-year-old Duong developed nearly a dozen high-performance compounds used by the Navy, Air Force, Army, and Marine Corps. After meeting with Ward, Duong accepted the challenge to cup with the potent payload the Department of Defense had requested, and the bomb maker had just what Ward was looking for: the PBXIH-135. A formula for an experimental explosive, the compound had already shown great promise in several tests. However, it had yet to be developed into a full-scale weapon. PBXIH-135. PBXIH-135 was made up of a standard military explosive called HMX, blended with a polyurethane rubber. The secret to the mixture was the addition of a precise blend of aluminum powder, which burned in the hot gases. While a typical explosion might last a few microseconds and course a few hundred feet down a tunnel, a thermobaric blast, fueled with aluminum and detonated in a confined space, can release 7 times more energy. Within only 60 days, Duong and her team at Indian Head had no choice but to disregard standard safety checks, forego any further testing, and create over 600 gallons of PBXIH-135 to cast it into bombs. After the PBXIH-135 was approved by the Navy and deemed safe enough to make a real bomb, the team ordered 20,000 pounds of HMX, pausing every other project they were working on. By mid-November, the scientists were mixing the ingredients and carefully measuring and pouring the compound into empty bombs. Although the first 2 bombs failed during the mixing process, the Indian Head team continued working under enormous pressure. Soon, a batch of BLU-118 B bombs was ready and sent to a Nevada test site. Success and outrage. By December 14th, the day of the first official test, the urgent need for the bomb had turned into desperation, as intelligence sources suggested that al-Qaeda founder Osama bin Laden was stationed in an underground compound in the Tora Bora region. As the bomb fell from 9,000 feet, Duong watched from a control room filled with television screens, analyzing the cave target both inside and out. While the final results took days to calculate, the conclusion was remarkable and unambiguous. The thermobaric weapon was a success. A week later, when the Pentagon released a videotape of the December 14th test and aired it on national networks, the world found out what the Indian Head scientists had been up to for the past 2.5 months. While the team of scientists was hailed by the nation as high-tech warriors, the international community was outraged, calling it a weapon of mass destruction, especially as some confused its name with napalm due to a similar designation used in the Vietnam War. The criticism caught the Pentagon and Duong off guard, and Lieutenant Ward and the Defense Threat Reduction Agency were forced to issue a press release, assuring the world that BLU-118 B was not nearly as lethal as its most ardent critics claimed, and confirmed that it did not violate any international treaties. A missed opportunity. After the bomb was dropped on March 2, 2002, and missed its target, 4th Fighter Wing pilot Captain Randall Haskin recalled the reasons for the bomb's failed delivery in an interview with the Aviation Geek Club. According to the pilot, there was always a 50% chance the delivery would not work. During the mission, as Haskin said, quote, "The pilot performed a last-second bunt to delay bomb release so that the weapons systems officer could get a better view of the designated mean point of impact. That's a normal thing for us to do with a standard laser-guided bomb." However, with the GBU-24 Paveway 3, the family of laser-guided weapons the bomb belonged to, the bunt put the bomb into a different flight mode than the one that was initially planned by the Air Force. As such, the bomb failed to follow the planned flight profile and thus smacked the ridgeline instead of the cave complex's entrance, missing its target. Still, Duong was proud of the achievement. According to the now legendary scientists, quote, "The BLU-118 B, to me, is another example of what is wonderful about this country. At a time that was supposed to be a moment of weakness, the American people work together, people of all religions and colors and backgrounds. I think it's a prime example of united we stand, united we fall, united we win. It makes me very proud. Thank you for watching our Dark Tech video. If you liked it, please give us a thumbs up and let us know your thoughts in the comments below. And for more historical content, subscribe to this and all the channels in our Dark Documentaries family. Stay tuned.